All right, let's think about this one. Find the domain in range. Well, we don't have any square roots, so it's not. I mean, the restrictions aren't any negatives. We can have negatives. However, we do have a fraction with a variable in the bottom. So this x cannot be 0. So that's the domain. Actually, that's the only thing that x can be. So you can, or sorry, that x cannot be. It cannot be 0. So you can say from negative infinity all the way up to 0, and also that's union. Also 0 to infinity. Or you can just say x such that x is not equal to 0. Because that's the only restriction on this. That's the domain. Again, about the range, well, we can plug in absolutely anything, and except for 0, which that's good. So I think, is there anything that we can't do? Let's think. A lot of the time, range is just a trial and error game if you don't have the graph, or if you don't remember how to graph it. I'm trying to do this without graphing, but if you can graph it and do it that way, that's fine too. So let's think. Well, if I plug in 1, what do I get? I get 2. If I plug in 3, I get a little bit more than 1. If I plug in 4, oh, as x grows, this entire fraction gets smaller and smaller and smaller, right? Ooh. Yeah, I'm gonna have to just think about the graph. I think that's the easiest way. So I can't plug in 0, so there's nothing on the y-axis. That's fine. If I plug in 1, I get what? 1 over 1, that's 2. 1, 2. 2. If I plug in 2, I get what? 1 over 4, so 1 and 1/4. So a little bit smaller than that. Plug in 3, I get 1 and 1/9. 1/9 is smaller than 1/4, so it's curving downwards like that. Does it go towards 0? Ah, let's see. So I'll plug in 3, 4. No, it's getting closer and closer to 1. Can we get to 1? I wonder. It's getting closer and closer to 1. If I plug in 3 million here, it'll be 3 million squared, and it'll be 1 plus 1 over 3 million. 1 over 3 million is a really, 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 really small number, but it's still a tiny bit bigger than 1. So it looks like there's an asymptote at y equals 1. Okay, at least in the positive x direction. Let's plug in something in between 0 and 1. Let's plug in 1/2. So that'll be 1/2. If I plugged in 1/2, what would I get? I get, well, 1/2 squared is 1/4. And then it's in the denominator, so I flip it over and multiply. That would be 4. So 1 plus 4 is 5. So that's way up here. Oh, okay. So it grows upwards like that. Is there... Actually, there's a vertical asymptote because I'm not allowed to plug in 0. What if I go backwards this way? If I start... Actually, if I plug in any negatives, I get a repeat because of that square. So it would just look... That's what the graph looks like. Remember, anytime you don't know what the graph looks like, you can graph anything. You just got to plug in stuff. Some people, I think, would forget to plug in something between 0 and 1. Remember, the only thing that we're not allowed to plug in is 0. So we have to think about stuff between 0 and 1. That's something that people would forget, I feel like. So the range looks like, now it's easy, looks like not including 1, but above it. So anything bigger than 1. That's what it looks like. So the range, I'll say y such that y is greater than 1. You can't say equal to because you can't make this 0. It can get infinitely close to 0, but it never actually gets there. The limit of it is 0 for this piece as x approaches positive infinity or negative infinity. So there you go for that one. Yeah, sweet. I like that one. Okay.